All right, we are back. We're going to go with 27. How is the electromagnetic spectrum used by scientists to study stars? There's a real long answer here about how stars emit the energy in wavelengths. We know that that can indicate temperature, with the hot stars being those high energy, low wavelength, gamma, ultraviolet, X-ray side. We've got our medium-sized star, which is like our sun, or medium temperature, I'm sorry, that's going to be our visible light in the middle, and then our cool stars is on the radio and infrared side with our low energy, long wavelengths. But we also know that it can show us age, it can show us distance, and like I just said, it can show us temperature. The type of EM wave that's collected by the Hubble Space Telescope, I mentioned earlier, that's visible light. That Hubble Space Telescope was that first optical space telescope, still in use today. It was launched in 1990. The electromagnetic waves that are able to reach the surface of the Earth, we know we have visible light, radio waves, and some microwaves. This visible light was with the refracting and reflecting Earth-based telescopes, and then the radio and the some micro would be those the satellite dish with the antenna there out in the desert. 30, electromagnetic waves are able to transfer energy through what media, which is plural of medium. They can go through solid, liquid, gases, and the vacuum of empty space. Planets and moons are different than stars because planets and moons do not make their own energy. They do not emit their own light. Stars do. We only see planets and moons because they are reflecting the light that these stars emit. Our sun is a star. We know it does nuclear fusion for energy. It gives off thermal energy, radiant energy, electromagnetic. We would not see our moon if it were not for the flashlight of the star. 32, how does Earth's atmosphere interfere with the operation of telescopes? It absorbs some of the electromagnetic radiation. It also reflects and refracts some. We know that when light changes mediums, it changes speed and then thus changes direction. That's why stars can look like they're twinkling. But we have this water vapor and this just blanket of stuff in our atmosphere around us, and unfortunately it only lets through visible light, radio waves, and some microwaves. So our Earth-based telescopes are pretty limited. Why do space telescopes collect more kinds of data than the telescopes on Earth? Well, because they're outside of the atmosphere, so this atmospheric interference is totally avoided here. And not only that, but it's really dark in space and there's no weather, so it's kind of like when you're driving and it's snowing, raining, sleeting. It's hard to see out of your windshield, and you've got that blurriness and that distortion. Well, there's no weather in space. The best location for each type of telescope, we have our Earth-based optical. It's going to be like this one with the mirrors of the lenses. It's going to be on top of a mountain, closer, a little bit less distortion, hopefully not as much light pollution. Whereas our radio is going to be in the desert, openness, dry, less interference of other types of waves and obstacles, like buildings and such. Space-based, we're outside of Earth's atmosphere and orbiting the Earth. That is why we know that space telescopes can gather more types of data, because we have eliminated that obstacle of atmosphere. Identify the conditions scientists look for to determine whether life can exist on planets other than Earth. Liquid water, organic molecules, and an energy source. So that energy source, maybe it's food, maybe it's the sun. Why is sending probes to the sun an important step leading to further manned space exploration in the solar system? We know the sun is super dangerous, really high radiation, charged particles, very hot. It could harm astronauts, damage spacecrafts. We're not going to get men or lady onto the sun, but it definitely poses hazards to all space travel. So we want to study the sun to better understand those hazards so we can be more successful in other space travel. Mars and Europa, which is a moon of Jupiter, have what in common? That would be possible signs of water. Stars appear to twinkle because we have water vapor, we've got gases, dust, rocks, just this, like I said, blanket of atmosphere around Earth, which is actually very beneficial. However, it can distort light. We've got this refraction, reflection, some absorption, makes this the stars appear to be light and dim, whereas they're not actually really twinkling. It's just kind of the playing of the light through the atmosphere. The speed of light is 300,000 kilometers a second. I know if you Googled it, you got like 299,998, something like that. How long does it take for the light from the sun to reach Earth? Our textbook supports 8 minutes. If you were to have done some sort of Google or Wikipedia search, I believe you got 8 minutes and 20 seconds. We're just going to go with 8 minutes here. Space probes. No, they are not designed to return to Earth. They use radio waves to relay messages back to Earth. And the part of the planet that's studied by space probes is going to be the atmosphere, the terrain, the surface. It does not bore down in and do anything with the core or the layers. It's really just the crust, the atmosphere, the outer visible part. The living creatures that are known to have been in space, we've got humans, chimpanzee, dog, monkey. And our artificial satellites here. Oh, I don't know where those answers went. Oh, they're down there. So monitoring. Military uses it for monitoring. We can monitor weather and climate. We looked at that map with the thermal imaging of the ocean temperatures during Hurricane Katrina. We also have this communication where it can transmit TV signals and phone. That can be for information. It can be for entertainment, communication. And then navigation or GPS is supposed to be up here. I don't know why all of that moved down. We have our global positioning system, navigation, that's for directions. The military can use it, cars can use it, boats can use it, airplanes can use it, hiking can use it. We all love Google Earth, and that is because of these artificial satellites. So when you're up kind of getting a bird's eye view, you can see so much more and see things in such a different perspective than if you were on the ground. So that is the second part of this study guide. Please let me know if you have any questions, comments, or concerns. Use your amazing vocab cards that you played with today. There was the Kahoot. I'll put that link up. I don't remember if there's a quizzes or not. There are documents. There's notebook pages. You have the PDF. A lot of you have the ebook that's been successful. So please shoot me an email, Canvas message if you have any questions, comments, or concerns. If not, I'll see you later. Have a great night.